Okay, so we're at that point in the topic where we get to the determining rule section. So we've got a cosine function here, and they tell us a little bit or a few clues that the amplitude is 5, the period is 10 pi. Okay, so let's get this done. So f of t is going to have an a value, or that a is equal to 5, because that's the amplitude. Cosine, we need to get this n value. Now here's how we do this. 2 pi over an n value equals the period that we're after. Okay, so I put the standard period of a cosine function here, the target period of the cosine function that we want, and its n value will be this one here. That's the value that's going to be the dilation factor from y. So let's transpose this. We've got 2 pi equals 10 pi n equals 2 pi over 10 pi. Cancel the pi's, 1, 5. Our n value is a fifth. Okay, so our cosine function is going to be t on 5. All right, so let's sketch this thing between 0 and 10 pi. So if our period is 10 pi, we're going to split that by 4 to get our scale, and that's going to be 5 pi on 2. Okay, so here is 10 pi on 4, or 5 pi on 2. This is going to be 20 pi on 4, which is 10 pi on 2, which is 5 pi. This is going to be, what's that? 10, 30 pi on 4, 15 pi on 2. And this one here is going to be 40 pi on 4, which is 10 pi. So in other words, we want one cycle of the cosine function. That's going to be -5, and that's going to be 5. There's no negative sign there, so we're simply going to start here, come up to there. Like so. All right, inclusive of endpoints. Now let's start to list our key features. 5 pi on 2, 0, 15 pi on 2, 0. The min happens at 5 pi, -5, and this endpoint here is 10 pi, 5. Okay, easy enough start. Okay, the graph shown is that of a function with the rule. Okay, so what we've got is a vertical translation here. Right, so let's have a look here, and what we can see really is we've got one cycle of the graph happening in 8. Okay, so that's looking good. Okay, so what I know is the period is 8. What else do I know? I know that it has gone, so the mean line, instead of being at 0, has gone up to 6. Okay, so it's trans up 6. The amplitude is going to be the distance from 6 to the top, or 6 to the bottom of the function, and we can see here that that's going to be a total of 11 take away 6 is 5. So the amp is going to be 5. Now also finally note that if we're going to do this, this is a sine graph here, okay, and this would be an example of a negative sine function. Remember, the standard sine function will go like that. This one goes the opposite way. So this a value, we're also going to make this negative. All right, so let's get cracking on it. We'll go y equals a, which is 5, our amplitude. It's going to be negative. We're going to go sine. All right, it's going to be something t plus 6. Let's work out this part now. So the standard period of a sine function is 2 pi. We're going to divide that by an n value, and we want the target period of 8. Right, so let's transpose that. 2 pi on 8 equals n. N is equal to pi on 4. So we're going to say that we've got pi t on 4 as our function. All right, it's worth your while probably using Geogebra to have a look at that. So I'm just going to fire up Geogebra and drag it in. All right, so this should be enough to see it. So we've got f of x equals -5 multiplied by sine pi times x on 4 plus 6. All right, let's have a look. All right, so mean line of 6 negative sine function and 1 full cycle is taking 8 units of time. So that's all looking very good and as it's supposed to. Okay, it also says find the values of A, N, and B. Okay, so we need to formally state that, in particular this A value. So we're going to say that capital A equals -5. The amplitude is 5, but the capital A, or this variable here, needs to be -5. N is equal to pi on 4. I do have that stated formally there. And the B value, I don't have that formally stated. That's going to be 6. Okay, so make sure you just check that you're answering the question. It's fine and it's great to get the full function, okay, but it says also that I want the individual values. And if you don't provide that, you are going to be losing a mark. Okay, so the final question, it's a bit of a toughie, this one, and I have to admit that I did get this one wrong in class last year, and it opened up some really good discussion. Okay, so what we've got is a rule with a horizontal translation of epsilon units. Okay, so we get a range of -2 to 2, period of 6, okay, and this tells us one thing, that when t is equal to 4, y is equal to 0. So we need to find values for a, n, and epsilon. All right, so what I'm going to do first of all is just imagine this as a function without the translation. Okay, so I'm just going to do a sine function first of all. So y equals, now a value at this stage is going to be 2. It's going to be sine. Period is 6, so 2 pi on n equals 6. 2 pi over 6 equals n. N is equal to pi on 3. Right, so 2 sine pi t on 3 is our function. Okay, now our scale is going to be like 2, 3, 4. So it's going to go like this. Okay, so there is our function so far. So what it's going to do is start at 0, 0, and what we want to do is send it that many units, or in that direction 4 units. Why do I want to do that? Because it says when time is equal to 4, the y value has to be 0. Now currently, when time equals 0, the y value is equal to 0. So I need to just horizontally translate this 4 units. Okay. So here's probably the easiest way I can think of it. Let's just say let f of t equal 2 sine pi t on 3. That's that graph there. Now what do I want to do? I want to send that graph there 4 units to the right. Okay, so what I'm going to do is say g of t equals f of t take 4. Okay, so I'm slamming t take 4 into this function, which will yield the result, or have the net result, of shifting this graph here 4 units to the right. So let's go 2 sine pi, and instead of t, it's going to be t take 4 all over 3. Okay, that's going to be 2 sine, and we're going to expand this out because I need to give individual values for these things here. It's going to be pi t on 3, take away 4 pi on 3. All right, and that's going to be our final function. Okay, so our a value is 2, our n value is pi on 3, and epsilon value is equal to -4 pi on 3. All right, again, let's just test that to see whether that's worked as it should have. So what I'm going to do first of all is just think about the basic. So it was f of x equals 2 times sine of pi times x on 3. All right, so there's our basic with the period of 6, and all I want to do is simply create a new function. So if I do f of, so I'm just going to make a new function g of x, which is f of x take 4, and that's our purple function. So let's get rid of the other noise there. So here's our new function, whatever it looks like, but it has the effect that, or that transformation has the effect that it meets the requirements. Now, girls, there's many different examples of solutions to this problem. This is just but one solution. So you could translate it even further. You could get this point to move over to there. You could pull it back in the other direction. There's heaps of different answers to this one. So this is one possible answer to it. And again, it's one of those cases in a SAC where if we ask you to do this, we've got to graph your function to work out whether it fits the requirements. So if you did try this one before or pause the video and tried it out, make sure you have a look at what your function looked like on the screen. Now, I'll just go into this a little bit further and show you what the mistake I did in class last year. It again was a shocker, so what I did last year was I got that one right and I got that one right. So I wrote the function down as y equals 2 sine pi t on 3. And what I did then simply was put the take 4 into the brackets, okay? And it's wrong, okay? If we look at the graph of that one, I'm just going to graph it. Okay, so the grey graph is what I said the solution was last year, okay, and it was very close, but there's no such thing in maths as close. It's wrong. It is flat out wrong. Now, see if you can think about why this might be incorrect, okay, and the difference between, say, this one here and this one here. And if you understand what's happening is this one here changes the order of the transformations. Okay, so this does the transformations in a completely different order to this one here. Okay, and that's the really important thing to understand. And so I think the best way to do these types of problems here is get the basic going and then use function notation to do the translation. If I thought about it or did it the other way, I'd find that I just couldn't actually get the order right in my head, and I would end up producing something like that. Okay, so the function notation for transformations really helps in answering this question. Again, be careful not to write that one down. That is wrong. All right, there's the exercise there, 6i. So get started on that one.